Hi everyone. In this video, I am going to go through like an overview and a couple of different basics of data containers, different data container types in Python, okay? And so as you can see my code in here, today it's quite different. And this now we started understanding PyCharm very well. We are, I would say, mastering how to use and all that. Now we are seeing a different interface. So this code is, I'm taking my screenshots not from PyCharm. Just I'm going to tell you that for this lecture, I am from the start, I was telling that there are different IDEs. If now PyCharm is done, I am making sure that everyone is able to work with it. You can run this code like on PyCharm itself, but I was explaining about Google Colab, that there are other IDEs in which I can run Python code. So I want in this class to go through Google Colab. I give you resources, some notebooks that you can explore. So mainly this is why the code in here could look quite different. Okay, now what I will do is that I'm going to go through the different container types in Python, and then I can go through the code and I will teach you how you can upload that, how you can read it online, even you don't need to download locally things. So you can work with Google Colab. If you probably will need in the future, I mean, not part of my class, to work locally, there is another alternative I told you before about the Anaconda, and you download it locally, okay? But for now, we keep things simple and clear. PyCharm, we are very good with that. We can even run this example on PyCharm. Google Colab, we explored it before, but never did a real example. So this is the best chance to work on that. And like the Zybook, I'm going to come back to that, okay? So like this, I will make sure that we can use different IDEs and we can handle Python in different, I would say, settings, okay? So so far what we did, so the variables that we have been working with, they have been associated with single value, okay? So for example, you know, for these lines of codes, for example, this should look totally fine, okay? They are pretty okay, and they are understandable, right? So here you are kind of first title now. You can interpret any code you can see. So first title, it's clear that, just pause my video, think of it. It's very simple. Okay, so just creating a variable. This variable name is title, and we are associating with it the value like singing in the rain, okay? Simple. We can next move to read or try to go through the next line. You can also pause and try to understand. Yep, it's very simple. This is another variable. We are associating with it the 1952, which is a number, okay? And this is also perfect. Then we have a different variable for which we are associating a single value, like a string in this case, and we are writing it like musical or comedy type, okay? John, okay? And then we have the runtime. Here it is an article, okay? So for all this, we are able to interpret, and if we will run this in Google Colab, we run this in PyCharm, whatever, we try to do some prints, this is what we will see, what we will see. And so we are fine with this, okay? So this is the first, I would say, stage. Next, things could be bit more complex, or for kind of more complex programs, we want to be able, for example, to store and to manipulate some collections of data, okay? So, for example, you can think of having beyond strings and numbers, you can have list of numbers, you can have kind of pairs, key and value, you can have sets, a set of items, and so on. So there are many other complex data types beyond the examples that we see so far, okay? And it's where basic containers, like here types, they are coming in this case. So each container probably is there to organize a collection of data in a particular way, okay? And so, for example, we have lists, okay? They are the first example of container types. Like lists, they contain what we call ordered sequence of elements, okay? So the elements now here that you have, they must be in order, okay? Next, we have sets. And sets, in this case, it's different type of container. And a set kind of contains an ordered set of unique items. So for lists, it's ordered items. For set, it's unordered, okay? And next, like we have the dictionaries. And so for dictionaries, they are directory. And so in other, like one, like it's the most common container, like let's say that you can probably encounter in Python. And so it's like contains an ordered set of key value pairs, okay? This is mainly the most used, I would say. And next, no, we have the last one, which is probably not that much used, or at least in this class, we are not going to go into details of for tuple, and so they are like at least worth knowing, okay? So they are like containers, immutable ordered sequences of elements, okay? We are not going mainly to use them, okay? So this is mainly for the different data types, okay? Probably there are other like containers, sorry, and we can find them available in the following links, okay? So in Python, so you can download, you can install, and you can work with the entire like libraries that you can like just need to include, okay, in your environment. So for each probably container, there is kind of specialized libraries, probably like for example, applications like sorting data in particular, like, but for now, let's just talk about these 4 types, and they're not that like difficult to manipulate. You'll see with the notebooks. So I'll give you, as I mentioned in the start, some notebooks. I will teach you how to open them with the Colab, and I'll give you the time to go through them. They're well explained. They are like with the details and everything. So now we are going to work for each of these types, and we're going to go through them. We're going to try to understand. So watch this video, and after that, try to walk through the notebooks, okay? This is what I expect from you for now, and that's it. So, okay, let's start with lists, okay? And so when you want so if you want to create, let's say, a new list, it's going to look like something like this, okay? And it could be containing probably only numbers, integer, I mean. It could only contain, for example, strings. Your list could be even empty, or it could be containing mixed items, I would say. And for example, you can see here, there are some like integers, numbers, some strings, and so on, okay? This is for lists. And as I was mentioning, it's ordered elements, okay? Now, when it comes to the order, it means that we can assign values at an index, which means that the elements, this is, for example, I would say the first one. Okay, we see this example, okay? This is the first one, this is the second one, and so on, okay? So when I make sure that when you're working with a list, it's ordered, and we start always with the index 0. So the element which is in the first position, it is the index 0. So for now, if I want to print or access to the first element, how that my Python interpreter will understand that this is the first element, it's when you just give it the index 0 here. So you just write your list number, and here, like just mention of 0. So nums of 0 here, it's going to return to you 2. Nums of 1 is going to give you the element which is next, which is the first, this is position, I would say 0, this is position 1. This is how we do, okay? It's going to return 4, and you keep going, names of 2 this one, names of 3 this one, but names of 4 is 32. However, sometimes you can have a list which is very long, you understand? So it has many elements. So probably you don't know list of 100 something. It's not a good practice, not could be the last element. So to make sure there is a trick to access the last element in your list is when you write the name of the list and you use just the index of -1. So -1 here is automatically going to go back, and you can see it as a circle. It's going, so the last element is always given as a result, okay? I wish things are clear. Now, how it works if we want to make some changes. So if I have initially in my names, which is the name of my list, this list of numbers 2, 4, 8, 16, 32. At a given point, I want to make some changes. For example, I want to change this 2 with a different number. So to make this change, first I need to locate my element. So here is the element of index 0 that I want to make the change. This is why I'm going to make names of 0. And here I am going to make affect a new value in that variable, okay? In that I would say first element of my list, okay? So it's 128. If we do that, then the updated or the changed and the updated list is going to start, instead of 2 here, we're going to have 128, okay? So this is mainly for lists, okay? You can add elements for a list, and in this case, like the size of the list is going to increase or grow. How to do that? There is a kind of predefined, like existing methods that we can use, like for example, append, okay? Append here, it's you are not supposed to learn this by heart, like I told you last time. Today we have, first of all, we have the documentation, which is a very important resource and valuable resource. So just you go to Google and you write, for example, list in Python documentation, for example, and you open the official documentation, you'll find all the methods that could be applied on a list as a data type, for example, okay? And in this case, like you will find not only append. Append here is to add an element. You can find many others. And for example, just to let you know how it works. So even like for the exam, it's open book, so you can do these things. You can search, just try to be quick for time purpose, okay? Now, let's say that we know that to add an element, we use some method, and this method, like before, we had dot title, dot upper, dot lower. This is dot append. So we use it in the same way. I have my list name, dot append. I'm going to apply this method on given that variable, that list. So, and what I will add? I will add, for example, 1024. Where I will add now the question? Automatically in Python, if you are adding an element to the list, it's coming in the last like position. So it's going to be the last element. So this is why here, if you have your list before 10, 20, 30, now it's becoming the same 10, 20, 30, but we are adding the 1024. It's coming at the end, which increases the size of my list from 3 elements. Now the list is having 4 elements. If I want to access the first one, it's so my list of 0, my list of 1, my list of 3, okay? Now, if I want to make sure if this element is added correctly or not, how I can do, this is the last element. So we said so far that if I want to access to the last element, I can just use the index -1. So kind of here, if you want to do it, you can just print, okay, my list, okay, you open your brackets in here and you put -1, so it's supposed to print for you 1024, okay? And next, there is another method that you can apply to a list, is to insert, which means if we are adding here, we are adding one element, okay? If we want to insert, then probably adding is going to add the element at the end. The insert is going, it's not obligatory at the end. You can add in the middle, you can add in the start, and so on. So here with the insert is kind you are fixing or giving, adding the value, inserting the value at a specific index, okay? So if, for example, I have my original list 5, 10, 15, I want to insert something, for example, at, I would say, the first position. So always remember, it starts with the 0. So 5 is a position 0. I will add first position, means it will come after 5. What I will add my like 1024. So the updated list, I will have the 1024 in the first position. How it works in terms of syntax? So when you call your method, it's dot insert. The first it takes, you have like 2 arguments, we call two elements that you will feed to the method. The first one, you need to affirm it where exactly you will insert, so it's the position. And the second one, it's what to insert, which is the exact, like, for example, number or string you can add or whatever, okay? Now, this is for adding elements to a list, okay? You can also remove elements. So if adding elements will increase the size of the list, now removing elements will decrease the size of the list, okay? So now how to do that? We add, is making out that element, we are using the method pop, okay? So my list dot pop is going straight automatically to remove the last value. So if I have my list here containing 10, 20, 30, so I apply the pop method, then I will remove, I would say, the last element, which is 30. So my updated list is going only to have 10 and 20, 2 elements. So the size is go from reducing from 3 to 2, okay? Next, I can pop a specific element, not the last one. Okay, by default is the last one, the same like a previous example. But if I want to force, like I want to remove the 10, which is, or for example, or 20, if I say the second, the element which is coming in the second position, which is having the index 1, because we start from 0. So here I will use the pop and I give the index. So here pop 0 will remove 10, pop 1 will remove 20, pop 3 will remove the last element, probably will have the same effect if you don't give the like index. So what we will do here in this case, we are going to use pop 1, which is going to remove the 20 from the list, so we will have 10 and 30, okay? Also, it's possible like to remove the first value, like which is equal to a given number, okay? So first we are going to say remove 10, okay? If I have my index, we are using pop. Now, if I have the exact value that I want to remove, make sure that it's probably in some cases, particular cases, I would say, you can have duplicated like elements in your list. Like you can have 10, then 20, then again 10, which means that 10 is having, you have it twice in your list. So what can happen? You apply this remove method, you give it the number you want to remove. It will only remove it at its first appearance, which means the first time it's going to find this number existing in your list, it will remove. If this 10 exists next, it will not get removed, okay? So for example, here what we have, if we try to remove 10, okay, it will just keep the other 2 elements, 20 and 30, okay? If, for example, let's suppose you are giving the argument here, for example, to the method remove, let's say my list is having 10, 20, 30, and I say remove 50. What can happen? So it makes sense that if the element or the X that you are giving to the remove method does not exist, then it will return for you an error, okay? So make sure that you are removing something that already exists. Here I'm keeping the link for more details if you want about lists, okay? We move next to, like, here I want to give you a brief overview about sets. So you can create a new set. And how to do that? So sets here you have it's different from the list. So in sense that here you have the curly brackets, okay? And you, just by using this, you are telling to the Python interpreter that this is a set, okay? And this is, for example, we created a set is having 2, 4, 8, and a set is unordered elements, okay? I can create also a set that has some like strings and, for example, A, B, and some numbers, okay? If the element, like here, there is in sets, we cannot repeat. Like if I'm create a set and I give 2, 2, 2, like 3 times, in this case, only one is going to be considered, okay? We cannot have it more than 1 time because just it's like a unique value for each one. So here it's unordered, and the values do not have indices like lists, okay? So you cannot access or update values by index. So sets are very efficient for checking if something is in the set, just like, for example, you use the in keyword. So to make sure that it belongs in mathematics, like how we do, if we have a group and we want to make sure if some like value belongs or not, we care about belonging and it's in or it's not in, so we can just use sets in this case. We can add elements to the set in the same way. So we use dot add 16. In this case, add x is going to add this number to your set in case this number does not exist, okay? So if we do, for example, add 2, so your set is 2, 4, 8, it will remain 2, 4, 8 because 2 already exists. Now you add 16, then you will have the size of your set will increase, then you will have 2, 4, 8, 16, okay? And if you want to remove now from the set, you can remove the element. So what you do, you apply the method remove x, and that is going to remove the, we don't talk about index, so for just that element, you're just going to take out or just to remove. If you are trying to remove something which is not existing in your set, then it makes sense that you will get an error again, okay? You can also use the method discard, and discard in this case, you give x, which is, for example, in our case, 4, and it's going to remove the value x from the set if it exists, okay? So it's more general because here, if it doesn't exist, it will not return any errors, this method, okay? So it's more general. And again, I'm giving you access with this link to more like details and documentation. And so now let's move on next type, which is dictionary. So for dictionary, they are kind of containers again, and they contain an ordered collection of key value, okay? When we talk about key values, so it's like pairs, okay? So let's see an example here. So in this case, what we have movie years. This is a dictionary, okay? And dictionary contains an unordered collection, as I'm mentioning, the pairs that you have, and its uses, again, like the sets, we use the curly braces in this case. So just like creating the set. So you are going, in this case, to use them and to create simply your dictionary. The difference here is that what we notice that each element or each item in this directory, it's a pair. It's a pair of what we call key and value. So here, this is the first element. It has one key and one value. Comma, then it's taking you to the second element. It also has one key and one value. Then another comma, you are moving to the third element, which is having a key and a value, okay? So it's kind of, you can see it as a table, and first row is the first element, it has key value. Second row, key value, key value, key value for each element, okay? So it's like this. And so this is the concept of pairing, okay? And the concept of pairing, it's based on this, like you can access any given value using that key. It's like we will see. So in the case like you have, for example, movie years, the first variable that we are assigning 2011. So what is the key for this? So the key is drive, okay, and so on. So first the key comes and then the value, and the same for the other elements, okay? So what type of how to access or how to manipulate directories in this case. So we can first of all access the values, like not like index with the list. Now we have important information, which is the key. So in directories, like we access the values given their keys. So if I have the key, I need to make sure that I write the key correctly and I have the key, okay? So if I mention here year, it's a movie years, which is by directory's name, of Greece, which is in this case. So it's going to return, this is the year value is 1978, okay? So just to make sure that we can access in this way using the keys, okay? And we access this for sure, like that we make sure that we open the square bracket, and just we mention the key. Don't forget that the key is always, like here it's a string, so okay, string, then make sure that it has the quotes, okay, double quotes. Now let's think of updating, sorry, the value of the one of the elements, okay, the dictionary, sorry. So how to update that? I know how to access, okay? I'm using the square brackets in here and I'm giving the key. So movie year, this dictionary, I'm accessing the element that is having the the key drive. So the key drive here, it's going to take you to this value, okay? So if I do like this and I make the equal sign, means I'm going to edit or make some modification and update the content of this one. Okay, so this one was previously 2011, equal here 2002. So I am just updating, so the new value is going to be 2002 in this element, okay? Okay. So next we can add new elements, or when I say element, it means one element is having the key and the value. So we can add new key value pairs to our dictionary. And for example, here, movie years, I'm adding the key, which is Hello Dolly, and I'm giving the value 1969. Okay, so we can remove a key pair from a dictionary, like using the method, like here we use delete, okay, just del we have, and then movie year drive is going to completely delete from here the first this element having that key, okay? And the keys are unique, by the way, okay? So then now what we have, movie year, if I try to do pop drive in this case, is going to give some errors because this element is already does not exist. It's deleted from your directory. This is one way to double check, okay? And again, I'm keeping for you the link to the documentation. So whenever you are exploring your, I would say, notebooks, so you can even try to understand more from this element. In addition to the Zybook, now we are becoming the experts of it. Okay, now we have tuple, as I mentioned in the start. So I just want to kind of give an overview, although we are not going to use this and it's not even part of this class, just want to let you know about them. So they are containers and types for sure, and they are immutable sequence of elements. Okay, which means that you cannot modify the tuple after it's created. Once it's created, then it's done. Probably this is the reason we will not use. So how to create new tuple? Just you are going to open your parentheses. You are giving it the list of elements, which could be like from your sequence, and these could be from different data types, okay? And this is what you mentioned, like inside of the parentheses, okay? So this is how to create a tuple, for example, which is already having the values 5, 15, 20, and hello, okay? And once you create this tuple, you cannot add anything to it, okay? You cannot change any of the values, okay? Anything like that, fine? So you cannot. What you can do probably is that you can access, okay? So you can access values in tuple. How you do that? Just by index again. And if you give tuple and 1 in this case, so to access the element at the first index, okay? And in this case, okay, the index for sure starts in 0, okay? We have 15 now is here is index 1, okay? So this is what it can return for you. Index 2, we have 20, index 3, we have hello, okay? So this is mainly it. But like because tuples now they are immutable, you cannot update the values as I'm mentioning. Add any values also is not possible. You cannot even remove values, and once it's created, so you cannot update, add, or remove. Okay. Yep. I think, yep. That's it. So now I try to cover all the different containers in Python, and I can let you explore and discover the notebooks that I'm giving you. Okay. Okay. So for now, what we will do is just I'm going to Blackboard in here. So I was just uploading for you a couple of notebooks I was telling you about for lists and different functions and dictionaries, sets, and so on. So now I will just teach you how to do, because I've received the question what to do with these things. Mainly for the code and scripts I previously shared, just you download it and you just open to see, like I always mention in my videos, try to see what code I wrote during my recordings. Now for this one, it's going to be your task just to explore, but I will teach you how to do that. So here you're clicking, I'm already downloading this. So I already have it in my laptop. So just I go and open new tab. And in this new tab, what I will do is I will open Google Colab. So just write, Colab for Google Colab. And then, so you, wait, you and this is your Google Colab. So whether you create a new notebook, if this is open for you, if not, you just go to, we went through this in the start. So what is a cell, how to execute, here there you write your code, here you can make it nice, not like, for example, in PyCharm, we don't have that where you write your like headers or text or things. So here just you need to upload file and then upload notebook, and you're already having it in whatever in your laptop. So I think I have it in the downloads. Yep. And so, for example, I will open the one for lists with some functions. Just click in there and it will open for you. You will see it online in case you don't have your laptop with you. For example, you don't have locally like installed some like IDE like PyCharm. You can use this case, which is I recommend if you don't work locally. So here you will read these are you have nothing to do with these like cells. It's only for you kind of a reading assignment. Let's just move in here. Okay, so you are reading this, and here you are having your cells. You are just going to run these cells, clicking here to run, and it's going to give you the output and let's say the execution. So this is the list having milk, eggs, cheese, and so on. So one way is to create a new notebook if you want to type everything by yourself, or another way is to come to this plus here and do plus, add subcode, and you try to create your own list. For example, you give different like names, you create different like variables, different lists, and different elements. So it's kind of hands-on experience of the content that I was already covering during the lecture. Okay, so you have the same for sets, you have it for dictionaries and so on. I think that's it for today, and thank you so much for watching. If you have any questions, never hesitate to contact me. I'm always available to help you. Thank you.